Small internal combustion engines power a significant amount of the world. They propel low-cost transportation tools such as rickshaws, small vehicles, and motorcycles. They create a means for generating electricity in remote areas, and they power water pumps, tillers, and tractors on small farms. Turbocharging the multi-million single-cylinder engines sold each year could reduce emissions and provide increased value for drivers, farmers, and all other small engine users. My name is Michael Buchman, and I am an inventor in the Lemelson MIT Student Prize competition. The goal of my invention is to improve the ubiquitous single-cylinder engine, creating a lighter, more fuel-efficient, cheaper, and cleaner power source. I am making this happen by turbocharging single-cylinder engines to make them more cost-effective. The amount of power an engine can produce is limited by the amount of air it can intake. A common way of forcing more air into an engine to get more power out of it is to use a turbocharger. A turbocharger consists of a compressor and a turbine that spin together. The turbine is powered by the excess energy in the exhaust gas, which spins the turbine and the compressor. The compressor compresses the intake air, forcing more air into the engine. This allows the engine to burn more fuel and produce more power. This technology is common in multi-cylinder engines to reduce weight, lower cost, increase fuel economy, and reduce emissions. Due to the pulsating nature of the exhaust flow, turbocharging is not currently used in commercial single-cylinder engines. The technology I've developed, modeled, and tested is a system that buffers the flow coming out of the turbocharger using an air capacitor. The air capacitor is a volume that rests between the compressor and the engine intake and stores the air between the exhaust and intake stroke. I modified an engine and built a test bed to validate this invention. It consisted of retrofitting an off-the-shelf single-cylinder engine with a turbocharger, an air capacitor, and a series of sensors. The turbocharged engine with the air capacitor was able to produce 30% more power than the naturally aspirated engine. This is similar to the power gain predicted by the model. The system I created increases power at half the price of increasing power by making the engine larger alone. This technology could impact tens of millions of small engine users by providing a lower cost power source with the added bonus of being more environmentally friendly than their current engines. I would like to thank my advisor, Professor Winter, and the rest of Gear Lab for supporting this work. I would also like to thank the National Science Foundation and the Tata Center for funding this invention.